Lesson 9.1, Video 3, Area of a Parallelogram. The formula for the area of a parallelogram is A equals BH, in other words, base times height, which is the same for the area of a square or a rectangle. But again, we have some rules, and that's that the height must be at a right angle with the base. So here we have three examples where a height is given as a dotted line to show the reader that that is officially the height. So if you look at our example, we have a parallelogram with the height given as 5, the base is 12. So the area of this parallelogram is base times height, which equals 60. Now we're talking area, so it's centimeters squared. I'm going to skip this next question and go down to C here first. So here we have a square, has an area of 16 square centimeters. What is the length of each of its sides? Now again, it's a square. So if we have a square, we have the properties that all sides are equal length. We know that the area, this is a parallelogram, so the area is base times height. Now because it's a square, we can modify this because base and height will be essentially the same value, so we can just write a side squared. In other words, side times side. So this is actually the formula for the area of a square, specialized in notation for a square. So here they tell us that the area is 16, and we are looking for one of the sides. So we would root both sides, and the side is equal to 4. Theoretically, it would be plus 4, but because it is applied for distance, it cannot be negative. So 4 centimeters. Now we'll go back to our last one here. This one takes a little bit more work. We still have the same formula. Area is equal to base times height. Now the base in this case is unknown. They want us to find it. They give us the area. But in order to find the base, we need to know the height. So this is where we're going to pull in some trig. If we focus on this triangle, this right triangle, we can use some trig if we knew this angle. Well, one of the benefits of a parallelogram is that opposite angles are equal in measure and adjacent angles add up to 180. So these two angles are supplemental. So if you take 180 minus 135, you'll get 45 degrees. That's just a property of a parallelogram that was discussed in quarter 1. Well, this allows us now to use trig, and we can say that the sine of 45 degrees is equal to opposite over hypotenuse. That's the 15 right here. Put that over 1, cross multiply, and h will be approximately 10.6. Now we can plug it in. So we have 180 equals base times 10.6. Divide both sides by 10.6, and our base will be approximately 16.98. And it's just a length, so units. And this ends Lesson 9.1, Video 3.